Dear students, welcome in CEC lectures. In this series, we are going to start the new series which is experimental physics. In experimental physics, we discuss the various experimental techniques used in the laboratories. We start with the optics lab, in which we discuss the Newton's ring experiment. I am Dr. Sonia Bansal from JC Bose University of Science and Technology, YMCA, Faridabad. In today's lecture, we discuss the Newton's ring experiment, in which we deal with the first, what is the aim of the experiment, then what is Newton's ring, or how we get the Newton's ring, then who discovered the Newton's ring. After that, we discuss the principle or procedure and methods used for the construction of the Newton's ring. After that, we discuss the methods and formula used in this experiment to find out the wavelength of the light. After that, we discuss that what are the calculation method. Then we discuss the application and what are the precautions we have to taken in the Newton's ring experiment. Now we start with the Newton's ring experiment. Now we see on the screen that what is the aim of the experiment. The aim of the experiment is to find out the wavelength of monochromatic light source. In this experiment, we are calculating the wavelength of light which are used, which we are using to get the Newton's ring. It is a monochromatic light, or it may be the white light. So, what is the aim of our experiment? To study the formation of Newton's ring in the air film in between plano-convex lenses and a glass plate using nearly monochromatic light from a sodium source. Sodium source is a monochromatic source which is having a wavelength of 5896 angstrom and 5890. So, and hence we will determine the radius of curvature of the plano-convex lens, and we also find out the refractive index of a material which is enclosed between the plano-convex lens and the glass plate. So, what is the aim of this experiment? Is to calculate the wavelength of light which we are using to get the Newton's ring. Second, if we use liquid or any other medium, then we can find out the refractive index of that medium. So, first we discuss what are Newton's rings and how they are generated. Newton's rings are the series of concentric circular rings consisting of bright and dark fringes. Now here we understand that we are dealing with the bright and dark colored fringes. It means fringes where we get from the interference pattern. So this Newton's ring experiment is the interference of light, where we use the two coherent source, or in fact we are using the two virtual coherent source to get the interference pattern which consists of bright and dark fringes, but in the form of series of concentric circular rings. How we get it? We use the plano-convex lens which lies on the top of plane lenses, or we can say when a plano-convex lens is mounted on the glass sheet, a small layer of air is formed between these two lenses, and the thickness of this layer gradually increases and the diameter of the rings also changes. So, in the Newton's ring, we get the concentric circular rings which consist of bright and dark colored fringes. It depends upon the what of type of sources which we are using to get the Newton's ring. Newton's rings are formed by the interference phenomena where we use the monochromatic and coherent rays of light which reflected from the top and bottom surface of the air film. This air film is in between the plano-convex lens and glass plate that we will discuss in the schematic diagram or the experimental setup of Newton's ring. The film thickness varies from 0 at the point of contact to a finite value in the wedge-shaped region. As we know that at a center there must be a contact point between the glass plate and the plano-convex lens. As it is a plano-convex lens, so it is in the form of the curve, and air film in between that gradually increases, because air film in between the plano-convex lens and the glass plate. Now, by studying the pattern of the concentric rings, we can find out the wavelength of monochromatic light. Now, this is a question how we will find out the wavelength of monochromatic light by using these concentric rings. And the refractive index of a given transparent medium present in the wedge-shaped film. As we are talking that there is air film between the plano-convex lens and the glass plate. But if we put any transparent liquid medium, then we can find out the refractive index of that medium which is placed in the plano-convex lens and the glass plate, and we are getting the wedge-shaped film. So, by this experiment we can find out the wavelength of monochromatic light and refractive index of the transparent liquid medium present in the wedge-shaped film. Now, if we use the white light instead of the monochromatic light, then the system will produce the colorful interference. Then we can get the various colors in the form of the Newton's ring. Since the condition of the maxima in the interference is dependent on the wavelength, it means at the center we are getting the white light. If we use the white light to get the Newton's ring, so we can use the monochromatic source like a sodium lamp, and we can use the white light to get the Newton's ring. Now, who discovered the Newton's ring? As the name suggests, Newton was the English physicist and mathematician who discovered the Newton's ring, and Sir Isaac Newton first observed this effect in 1704. But in 1717, Sir Isaac Newton studied the ring's pattern generated due to the interference of the light. These rings we get because of the interference of the light. So, this is the one of the type of interference. Interference divided into two parts. One is the interference due to wavelength. Second, interference due to amplitude. So, this part of interference is interference due to amplitude. So, we are getting the Newton's ring by the formula of interference of or splitting of amplitude. Since Newton's ring pattern is a result of interference between the partially reflected and partially transmitted rays from the lower curved surface of the plano-convex lens and the upper surface of the plain glass plate. As Newton's observed, as it is a requirement to get the interference pattern, is that we require the two virtual coherent sources. Now, we are saying that a single source monochromatic light is used, but we just split it into the two virtual sources. So, how we get it? The two virtual sources to get the interference, one part of the light transmitted from the plano-convex lens and other part transmitted from the glass plate. So, Newton's ring pattern is a result of interference between the partially reflected and partially transmitted ray from the lower curved surface of the plano-convex lens. One light we are getting transmitted from the plano-convex, lower part of the plano-convex lens, and the second ray we are getting from the upper surface of the plain glass plate on which the plano-convex lens is mounted. So it was observed by the Isaac Newton in 1707, and he observed the interference pattern. What is the principle of Newton's ring formation? If we talk about the principle of Newton's ring formation, this phenomena is the formation of Newton's ring, which is explained on the basis of wave theory of light. Newton's ring may be defined by the wave theory of light. That interference is the part of the wave theory, in which air film of varying thickness is formed between the lens and the glass sheet, and from where the light is transmitted. When a ray is incident on the surface of the lens, it is reflected as well as it is refracted. Both the phenomena will take place, reflection and the refraction. What is the principle? Again, when the reflected ray strikes the glass sheet, it undergoes a phase change of 180 degree on the reflection. It means there is a phase change of 180 degree when it is refracted from the glass sheet. Interference occurs between the two waves that interfere constructively if the path difference between them is m plus 1 by 2 divided into lambda. Interference, if we talk about the constructive interference, then the path difference between them is m plus 1 by 2 into lambda, and if it destructively, then the path difference between them is m lambda. Sometimes it is mentioned n lambda, n plus 1 by 2 lambda or m lambda, thereby producing the alternative bright and dark rings. So in the Newton's ring, we are getting the alternate bright and dark rings in the form of concentric circles. Now, what is the apparatus used in the Newton's ring? Now we see that what are the part in the Newton's ring experiment. The apparatus consists of the following components. Number 1, monochromatic source. Most of the time we use the sodium light that produces the yellow color output. Second is plano-convex lens, glass plate, optically flat glass plate, convex lens, travelling microscope. Every part plays important role for the construction of the Newton's ring. So how it is important? Now we just take one by one. Monochromatic source, that is a sodium light, which is used to get the Newton's ring, and we calculate the wavelength of sodium light, the source which we are using. Plano-convex lens, which is mounted on the glass plate, and in between them we get the air film. After the convex lens, one glass plate is also used, which is near to the source, that is used for the reflection of the light. Then we use the travelling microscope, which gives the output, which gives the reading. Now we see that here in the diagram or in the figure, that there is a various part. This is the instrument which we use in the laboratories to get the Newton's ring. So in the wooden box is the source, monochromatic source, which we are using to get the Newton's ring. Then there is a telescope holder that may be put up and down so that we can get the Newton's ring in a focused manner. Tilting screw that move the telescope through, and there we can get the exact and best position of a particular ring by moving this tilting screw. It means we can put a cross wire on a particular ring by using this tilting screw. Focusing screw that will focus the magnification or focus the Newton's ring, and so that it can be easily monitored. Beam splitter, which divided the beam into two parts, how there is a arrangement where we are having the plano-convex lens on the glass plate. Main scale, in this apparatus, we just note the reading which consists of main scale, vernier scale, so that we can get the exact reading. Source of light, as we know that it is in a wooden box. Eyepiece, through which we can see the Newton's ring. Objective lens, which is required to adjust the Newton's ring, or adjust the location, or adjust the focusing of the Newton's ring. Now here see, we are just going close to the apparatus. You will see that this is a source of light. The bright light in the yellow form is the source of light. Then beam splitter. Beam splitter means we are having a arrangement of plano-convex lens which is mounted on the glass plate. Then this is the closest arrangement, and we see that how the light is falling upon a plano-convex lens which is on the glass plate. Now, what is the procedure and method? We see in this diagram, this is a very simple arrangement, and we are getting a good Newton's ring. Now see in the diagram, there are the various parts which we discussed and their use. First we discuss from the sodium lamp. Light, which is a monochromatic source, fall upon a glass plate which is mounted on a 45-degree angle. From the source, light fall upon a glass plate which is mounted at the 45-degree angle. From this glass plate, it is mentioned with G. From this glass plate, light will be reflected towards the arrangement which is plano-convex lens, which is C, mounted on a plain glass plate which is represented by a B. Then from here it is reflected towards the travelling microscope, where we will observe the Newton's ring pattern, or we can say we can get the bright and dark circular rings, and these rings are known as the Newton's ring. Again I repeat that this is the arrangement. You see here more clearly in this diagram that how we are getting the Newton's ring. The light from the sodium lamp, there is a slit. From here light pass through the convex lens, then it fall upon a glass plate which is mounted at the 45-degree angle. From this glass plate, light will be reflected towards the plano-convex lens which is mounted on the glass plate, and there is a air film between the plano-convex lens and the glass plate. From here light will be partially reflected from the lower part of the plano-convex lens and the upper part of the glass plate, and on the left hand side Newton's ring pattern we are seeing. That this pattern we will get from this experiment. These are the concentric circular rings. So this is the method to find out the Newton's ring. Now what is the procedure and method? As we discuss step by step. Number 1, experiment setup, as we have seen in the figure, where we are having a convex surface of a plano-convex lens having a long focal length, large radius of curvature, which is placed in the contact with the glass plate and clamped together. Means we are having the arrangement of plano-convex lens on the glass plate. Now we use the monochromatic light source, which is sodium lamp, which allowed to fall on the convex lens which is just near to the source through a wide slit. Now here we are using the word wide slit. Wide slit means we use the broader or intense source to get the Newton's ring, as it is a condition of the interference due to amplitude, where we use the broad source and narrow source we use in the interference due to wavefront. So here we are using the wide slit because we are dealing with the interference due to amplitude, which renders it into the nearly parallel beam, and this beam fall upon a glass plate which is inclined at 45-degree angle vertical before reaching the lens plate system at the bottom. From this convex lens, light fall upon a glass plate. From here it is reflected from the upper surface of the glass plate and from the lower surface of the lens. As we are require the two virtual sources. After that, due to air film formed by the glass plate and lens, interference fringes are formed, which can be directly observed by the travelling microscope. And these rings are concentric circles, where the center bright or center dark. A center dark spot is obtained when we viewed by the reflection, means we can get also the bright fringe. So from here the light form the concentric circles which produce the circular interference pattern. Then what is the theory and equation behind it? As first we see that how this now here we are seeing that how we can get the two virtual rays for the interference pattern. Here see in this arrangement we are having a flat glass plate on which plano-convex lens is mounted, which is also made of the glass, and you see on the left hand side there is a air film n is equal to 1, which represent the refractive index. Sometimes it is written mu is equal to 1. So air film is in between the glass plate and plano-convex lens. Now see, the point C is the center point which is in contact with the flat glass of the plano-convex lens. Now see a ray from the light, right hand side you see that a ray of the light fall upon this arrangement. Then we are getting the two virtual sources, or we can say the light when fall upon this arrangement, the light reflected from the lower part of the plano-convex lens towards the eyepiece, and the second part reflected from the upper part of the glass plate, and these two rays are coherent and these two rays are in a phase, and then they produce the interference pattern. Again we see here that the ray fall upon a plano-convex lens. At point P it is reflected towards the eyepiece, and other part is reflected from the upper part of the glass plate at point P2, and ray 2 is formed. So this ray 1 and ray 2 produce the interference pattern in the form of concentric circle. Again we see in this diagram that at the center these two arrangements are attached. C is equal to thickness is 0. As we see that we are moving gradually outwards the apparatus, then we see that the thickness is changing. So this thickness changing form the concentric circular rings. So we are dealing with the theory and equation which are used for the formation of Newton's ring. Sometimes we say that how we will get the formula to get the wavelength of the light. So we consider the ray of light which incident on the air film at the point where thickness is T, and the optical part difference between the two reflected rays will be 2T. So we require the ray of light which fall upon a which fall upon a glass plate. From there it is moved towards the arrangement where the plano-convex lens is mounted on the glass plate, from where it is reflected towards the eyepiece, and these two rays must be in a phase, so that we can get the interference pattern in the form of concentric rings. So from this we are getting the Newton's ring. If we use the yellow light, or we can say we use the sodium lamp, then we get the yellow concentric circles. If we use the white light, then we can get the colored fringes, but the center depend upon the center ring depend upon the monochromatic source or the light source which we are using. Thank you very much.